In this video, we'll look at solving formulas that involve some quadratics. In the first example, we want to solve this formula for b. Since b appears in one spot, we can solve it simply by isolating b on one side and placing everything else to the other side. So let's subtract a squared and c squared from both sides of the equation. We end up with b squared equals d squared minus a squared and minus c squared. And then, to leave the b by itself, let's take square root of both sides of the equation. So square root of b squared will give us absolute value of b, and square root of this expression has to stay as it was. There's nothing we can do about this. Okay? Therefore, b by itself is given by the formula plus or minus square root of d squared minus a squared minus c squared. So formally we have two possibilities, positive or negative root. However, if we for example know that b represents a distance, then we'll neglect this negative possibility and give the answer just as a positive root. Let's see the second example. We need to solve this formula for x. Since our variable x appears in one spot, we can still solve it by isolating it. However, it is in the denominator, so the first thing to do would be to move this x squared to the other side. Formally, we are going to multiply the entire equation by x squared. And in the meantime, we can move the m to the other side to the denominator. So formally, we are going to divide the whole equation by m. Okay, let's do the swap of x squared and m. Therefore, we have x squared equals, copy the rest, m1, m2 over 2, and then m travels to the denominator. Fantastic. Now again, to reach the x by itself, we place square root on both sides of this equation. So our x is equal to plus or minus square root of m1, m2 over 2 times capital M. Here we go. The next example looks a little bit different than the previous two. How come? Well, the variable r that we need to solve for appears in two places, and it's not only this. Each r is raised to different exponent, so there's no way that we can rewrite this formula with just single r in one spot, for example by factoring. Factoring here wouldn't help just because of this difference in exponents, right? So in such cases, what we can do is treat this equation as quadratic with respect to r. For example, if we bring the a to the other side, we get pi r squared plus pi s r minus a equals 0. So now the left-hand side of the equation is a quadratic trinomial with respect to r, with coefficients pi, pi s, and negative a. And since any quadratic equation can be solved by using quadratic formula, well, we can apply this strategy here. So our r, either 1 or 2, there are two possible roots, equals 2. And then we want to follow the quadratic formula. So to make it easier, let's list on the side what's our coefficient a, b, and c. A is equal to pi, b is equal to pi s, and c is equal to negative a. Let's use this information. So we're supposed to write negative b, meaning negative pi s, and then plus or minus square root of b squared, so that's pi s squared, pi square s squared, minus 4 times a, which is pi, times c, which is negative a. Everything over 2 times a, so in our case is 2 pi. Okay, therefore our r, 1 or 2, equals, and let's see if there's anything to simplify in this root. Well, not really, because there's no perfect square common factor. The only thing that we could do is to combine these two signs as a plus. So we have negative pi s plus or minus square root of pi square s square plus 4 pi a over 2 pi, and that's our final formula. Here we have one more example. This time we want to solve for v. This is a formula that relates the mass m of a moving object at velocity v to the mass m0 of the same object at rest. And c is actually a constant, the speed of the light. Notice that m and m0 represent two different quantities. Okay, so how can we solve for v? First of all, v is in the denominator, and it's also hidden under the radical sign. However, the good part is v is only in one spot. So the plan is to move the v to the numerator and try to isolate it. Okay, so to follow the plan, we are going to multiply the whole equation by the entire denominator, the square root of 1 minus v squared over c squared. Therefore, on the left we have m times square root of 1 minus v squared over c squared, and on the right just m0. Now, since we want to get closer to v squared, let's get rid of this m. So the second step would be to divide the whole equation by m. We end up with square root of 1 minus v squared over c squared equals to m0 over m. And the following step would be to get rid of the square root. So square both sides of the equation, right? We're squaring this side and squaring that side. So we obtain 1 minus v squared over c squared equals to m0 squared over m squared. Next, to get closer to v, we wish to leave this term, but maybe it's a good idea to leave it with a positive sign. So my suggestion would be to move this whole term to the other side. In the meantime, move this term with m's to the left-hand side. Okay, so on the left we have 1 minus m0 squared over m squared, and on the right we have v squared over c squared. In the following step, I would suggest to make a single fraction out of this left-hand side, and since we like to have our variable on the left, let's start writing from the right to the left. So we'll have v squared over c squared equals common denominator m squared. In the numerator, 1 becomes m squared over m squared, so we'll write m squared minus m0 squared, right? And now a couple more steps. We are nearly at the end. Let's write it here. V squared by itself would be equal to whatever we had on the right times c squared. So formally we multiply this whole equation by c squared, right? Okay, therefore c squared goes into numerator. C squared bracket m squared minus m0 squared, everything over m squared. And the last step, to get rid of this perfect square, we apply square root on both sides of the equation, leaving the final answer as v equals plus or minus, and now we can distribute the square root to each factor of the radicand. Square root of c squared is just c, that's a numerator. Square root of m squared is just m, that's denominator. But square root of this bracket, well, we can't really simplify it, we have to stay with it. Square root of m squared minus m0 squared. This whole radical expression can be written in the numerator. So here it is, that's our final formula. If we know that the v is supposed to be positive, we'll drop the negative sign here. Please solve a lot of formulas to become fluent in it.